Hey there, I'm Alan Furstenberg,
And I am Mark Tucker, and we are Two Voice Devs.
Two Voice Devs. Welcome back, everyone. And as always, it is fantastic to see you, Mark.
Thank you. Same with you. It's been a little bit since we've talked.
A little bit. We took a break in there because we had a backlog that we could catch up with, fortunately.
Yeah, but it's definitely good to we're getting towards the end of the week, and it's nice to spend a little time with you talking about whatever we're going to talk about today with developing for voice assistants and the technology behind it.
It is. It's funny. We record these usually a week or two ahead of time, as most people know. And I discovered earlier today that it had been 2 years since I first started joining Voice Lunch.
Oh, man, that's cool.
It's amazing to see the people that were on that first one. And just to think about all the conversations that have taken place since then.
Yeah, all the people that have met and the conversations in Voice Lunch and outside now
right.
that we're friends on social media.
It's been wild. And it's always fun talking with people outside Voice Lunch, either on Twitter or on LinkedIn or in my office hours. I get all sorts of interesting questions sometimes.
Mm-hmm.
And I kind of alluded to one on Twitter a few days ago that Dana, who has been the basis for a number of questions here.
Thanks, Dana.
As always, thank you, Dana. Asked a question in office hours, and we dug through it and eventually solved the problem. But it got me thinking that it's actually a really, really common problem that we see with people who are accessing databases primarily. And I thought that might be something that we can talk a little bit about today, or some of the challenges that we end up with when we try to access databases and then get them into a voice response. And just how in general we use databases.
Wow, databases. That's been something
tiny topic. Nothing.
Tiny topic. Well, that takes me back to for one of my courses in college. I had the SQL 92 standard book, and it was still fairly new, just a few years old, and wow, I took a database class, and so it's just SQL databases is where things started for me.
Well, the funny thing is, I know that feeling well. The database class that I took in college, and I still have that book, only dedicates about a third of the book to SQL databases. The rest of it discusses various other database technologies that were very popular at the time, including network databases, where you had databases that had objects, and these objects pointed at other objects, other records, and it was very interesting. And large parts of the book talked about database optimization. And when they meant optimization, they meant, how do you store stuff on the disk so that when the read head, so as the disk was spinning and the read head would come around to the data that you needed to read, it was most likely to be there, as opposed to having to spin the disk around again. That was database optimization in those days.
Isn't that crazy? We're talking about disk heads. We're talking about man, things have changed.
Right, and now mostly, we're thinking about our disks are solid state drives in a lot of cases, and we're talking about optimizations about doing caching to more nearby memory. And we're not just talking about SQL anymore. We're talking about all sorts of NoSQL and object databases and so forth. So it's always interesting to see how things change, but also how things remain the same in a lot of ways.
Well, and you also have not just kind of NoSQL, but you have kind of this hybrid kind of coming from the spreadsheet side of things. You've got things that could be spreadsheets, but are like spreadsheets plus plus. Things like Airtable or Monday or things like that.
Mm-hmm. And and also you've got interesting databases where they're pushing you data. If you make a query once, And as long as you keep that connection open, you just keep getting more data that keeps coming in.
Right.
Or, we now have to deal with the fact that, we can specify page sizes of how much data we want at a time and get it in those chunks that we want it. So lots of things that we need to think about that, the SQL 92 standard didn't think about.
Yeah, things about, dividing things up into tables and join tables and inner joins, outer joins, different normal forms, all the stuff that you would need to do for a SQL database. I haven't had to think about that for a long time, actually. On the stuff that I've worked with, and
part of it is that the databases have optimized a lot of that internally, and some of that is that our considerations have changed. It used to be that the databases were structured to generate reports. So, we would be thinking about large tables, massive tables that ran a report once a week, and you just needed to make sure the report was done by 9 a.m. or whatever. Yeah. Now we need to think about, queries and make sure the query returns in under 5 seconds. Yeah, because that's how long we have to give a reply to the user by voice.
Yeah, and it's also changed in the fact that sometimes, used to be you made a connection to your database server and you sent, queries to your database and got values back. But now more and more, you're exposing the CRUD operations, create, read, update, delete, from your database through like a REST endpoint or GraphQL or something else, so that in essence, your data store is more of an API now, as opposed to a separate, treated differently connection directly to a database.
No, that's a great point. And even queries now are more what we used to call query by example.
Yeah.
So, that used to be a really, really popular term for a while. And now it's just kind of, we're just, telling you which fields we want which values to match, and you send us the matches, Yep. It doesn't seem as big a deal anymore.
So what kind of databases have you used, like on the NoSQL side of things? Like most of what I do is like Dynamo DB.
And I've used Dynamo DB, and I do a lot with Firebase and Firestore.
Right.
And they're all similar. They're not identical, but they're all similar. They have the same kind of flavor to them.
Yeah, and we'll kind of throw MongoDB in kind of in that mix.
And I would even say that, some of the queries that you can do with Airtable are also kind of that same sort of flavor, because they're largely query by example, especially on things like Dynamo DB and Firebase. You're kind of limited that you can efficiently only really do queries against indexes that you've already defined. Mm-hmm. And they limit those to make sure that you've got speedy returns, that that it can return the value quickly.
Yeah, and so it's good in
our case.
and there's kind of like a little bit different flavors. Like in Mongo, you're dealing with documents, which are just really JSON in the end. Whereas like Dynamo DB, in the end, it's kind of more of like a key value store in some ways, but it's got like a partition key and a sort key. And I came across a few years ago a really interesting book by Alex Debris, and it's a continuation of work that others have done at Amazon. But it's this concept of single table design, where you don't have multiple tables in Dynamo DB to deal with, people and things and that you merge those together all into one table, and you use partition keys and sort keys and indexes to get things out of that table.
I think that's one of the things that has been hardest for me to unlearn when I work with Dynamo DB, is that you really, most of your stuff will be in one table, and you use the partition key to kind of differentiate between the kinds of data that you're looking for.
You can like prefix something, maybe something has an ID, but you prefix that with like person or user or score or, whatever it is. And then you can either grab something directly by the whole key, which includes the identifier and like the selector, I guess, or what would be the table. Or you can say, I just want things to start with users, and it will give you back in the sort key order, kind of like a whole table scan of everything
Right.
that's in that person table.
And the great thing about it is that if you filter on a partition and then give a range for your sort
Yep.
key, it can do that fairly efficiently because, as the name implies, the sort key is sorted. So if you give it a start range and an end, a start and end to the range, it can go right there, go straight through, and then be done. It doesn't have to do anything like resort it. There's no optimization along those lines. And indexes work exactly the same way. Since they're indexed, which is really creating an artificial sort key, it has, it knows the start, it knows the end, it goes through the records and gets them back to you. Firebase is similar. It's the same, and it's similar. It doesn't have the notion of a partition key, but all it has is one huge object table. And from there, you can put indexes on it. And those indexes, you can say, give me all the stuff for this index between here and here. And it can literally just go straight through it and pull up the results for you. So similar concepts on those. I think the big challenge for voice developers, particularly when dealing with all of those, is that, and especially when we're working with JavaScript and Node.js, is that these operations are asynchronous operations.
Yeah.
So we need to keep in mind that when we do a query, we either need to await it or use a promise or a callback on some sort. And then we start getting into challenges. Well, okay, how do we do that asynchronously when Alexa or Google is expecting a response essentially synchronously?
Yeah. And a lot of times I ended up just awaiting for the response, because I don't want to be in that situation where you're done with you're done and sending the response back, and you finally actually getting the data.
Well, and that's always the problem, is that the first time you tend to try it, because you're going to try it the first time, you're going to put in console logs, right? Because everyone does. That's how you know it works.
Yeah.
You've taken the code from, and this was the problem that we encountered with Dana, is that the code sample from Airtable didn't use async and await. It used a callback. So in the callback function, you did the console logs, and you can see, sure enough, it was making the call, it was getting the data back, it was looping through the data and printing it out, and it seems like it should work. But what ends up happening with JavaScript is that callback function is that the way it gets set up is that it kind of makes the query and then goes on to the next statement in your program,
right?
Which on a voice agent tends to be the thing that says, send this response back to the user.
Yeah.
And you don't understand why Alexa or Google says, you didn't send me back a message. And you're looking in your console log saying, but I clearly am getting the data and I'm setting it to the variable that I expect. Why didn't this work? And the reason why it didn't work is because your callback function got called after your reply got sent back.
Yeah.
And to untangle that, the easiest way is to use await. Await for the response to come back, go through the response to get the data that you need, build your reply, and then send that reply. And that's JavaScript. It doesn't make it hard, but it doesn't make it obvious in a lot of cases that that's what's going on. Yeah. And that confuses a lot of users.
Yeah, because Well, because of changes in JavaScript over the years, where it started with callbacks, and then you could do thens, and then you can do
but remember,
await.
in Node, even before callbacks, you had event handling.
Oh
So
man. Well, that predates me on Node.
it used to be. I mean, it was, in some ways, it was kind of brilliant. You would say, I'm going to make this network request, and I have an event handler that says when I get the headers, and I have another event handler that says when the data starts to come in, and another event that says I've gotten another chunk of data, and then another event handler that says all of the data is here. So you set up event handlers to collect the data as it comes in and store it in a variable, and when it's done, then you do your processing. It was elaborate and complicated, but it worked. And
Yeah.
it was very JavaScripty. JavaScript always had this notion of events, so doing it that way kind of made sense, but man, it was hard to follow sometimes. And then we had callback functions.
Yeah, no. So I think I've stumbled across some of that older code where I'm like, and yeah, and I think there's even some things that still do that. But yeah, so JavaScript has changed over time, which is complicated. Plus, you can use Node for various things. It doesn't, a voice app, a web app, console scripting. There's all kinds of ways that you can use Node. And so some of the examples that you get might be, focused or biased towards one of those, formats and uses, and you don't necessarily know. You're like, oh, this is a good, short, succinct example. I'm just going to use that. And then, then you're like, oh, not sure what's going on. And it could be challenging.
Right. And, if the documentation doesn't make clear, this returns a promise, or I don't know what a promise is, because that was, in that intermediate period in between when callbacks were popular and async await was popular.
Yep.
There was this brief time that we had promises that we needed to use, and
then there were like libraries that did promises before promises were baked into Node.
Right.
So
and libraries that do things like, if you pass it a callback function, it'll call the callback function. Otherwise, it will return a promise. So it works for every legacy code still works, new code still works. So there's still a lot that's confusing out there. But either way, almost everybody supports promises these days.
Well, this is an interesting kind of a sideline on promises, is that, I've hit situations where, and this is the bane of any voice developer, is a chatty REST API, where you're like, I'm going to get a list of restaurants, and I need to get, for those restaurants, I need to get the details of the restaurant. That includes the address and other things. And for that restaurant, I also need to get calendars of when it's open. And then you could, for example, here's a scenario. Let's say that you get back, you want to get recent orders or something, and the API call gives you a list of the most recent 5 orders. So then you'd have to check each of those, or go through each of those orders, find the restaurants that pertain to each of those orders. You might need to, maybe it's just the order kind of summary information, and to get details, you'd need to make an API call for each of those orders. And before you know it, you've got 20 API calls that you need to make as part of this, even just kind of setting up the welcome, your last order was blah, 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 blah at location such and such, right? But in some cases, you're out of luck. If there's that many and you have to do it in serial, then there's just not enough time in that 5 to 7 seconds that you've got. If you luck out, though, there might be situations where you could make a whole bunch of calls in parallel. So a whole bunch of promises, and then bring those back in, and then deal with it. So in essence, the length of time is the length of time of the longest API call is the most that you have to wait. And then you have like these 20 results that you have to then compute and do whatever. So that's great. But this is something that I ran across in a project recently where I was using a promise and I was doing it in parallel. And it actually, one was dependent on the other. And it's, even though I listed A and then B, it's not guaranteed to execute in the order that it was in the array.
Mm-hmm.
So what was happening is that I really needed to call A to set up something in my back end so that when B got called, then it was valid.
Ooh.
But it was calling B before A.
That's, yeah, dependencies like that are hard to figure out sometimes.
Yeah.
Because we expect each of our database calls to be independent of the others.
Yep.
So that kind of thing can be really tricky to figure out.
Yeah.
One of the challenges that I see a lot of is that, and not so much in voice, because usually in voice, we don't need to get 20 stores, but we want to get a list of 5 stores.
Mm-hmm.
So currently a lot of databases, when you make a call, they'll return page sets or pages of results. So it used to be when you did an SQL query, you would set up something called a cursor.
Yep.
And at each, it's kind of like a loop. I don't know why they gave it a different name.
Yeah.
But each loop through the cursor would give you one more result.
Yeah.
Nowadays,
in essence, move the index or the pointer
right
to the next one. Yeah.
Nowadays, what we see is that you're tending to do more like get batches of 5 or 10 results at a time.
Yeah.
And then using some kind of method to say, get me the next page of data. Mm-hmm. And that's because that's how, websites like to operate on a, they like to show 10 items or 20 items or whatever. And there's no point in fetching 100 items when you just need 20 items at a time.
Yeah. What you'd like to know is like, here are the 10 or 20 items, but I also want to know the count of everything that would have returned in the query. So you're like, you have 312 results. The first 5 are this.
Right.
Yeah.
And, so we need to increasingly structure our calls or make sure that our databases can handle as part of the queries, returning both the total number of records and just returning a page size of 5 or whatever.
Yep.
Because that in voice, that's great to handle. And then be able to say, okay, if the user says, keep track of that page index so that when the user says, give me the next page, we can now go to the database and say, oh yeah, give me the next page. So you have things like a next page identifier. So you can just say, I don't need to rerun this query. Just give me whatever the next set of data from this identifier would be.
Yeah, just store as a session variable what the
right.
Yeah. So what a lot of times I make that API call and I in session storage. Then I keep the results of that query. So I've got the 5 items in memory, and I have a pointer to like I'm at index 0. Because I could deal with it a number of different ways. I could still on the UI iterate through them one at a time if I've got a lot of information that I need to give about each item. But if I wanted to just give like if it's movies, like 3 movies that are close to you are this, and this. If I'm just reading off the titles, then maybe I want to say all 3 of those at once.
Right. And the user then may say something like, well, tell me more. What are the times for this one?
Yep.
And if your query's been done well, you can keep that information in the session storage and not have to go make database queries again.
Yeah. And if they say more, then you can say, oh, I can either, if I still have that value, if I had fetched 10 and I'm only doing 3 at a time or whatever it is, then I could just, kind of still use the results that I cached in session and get the next thing out. Or maybe I just want the page size to be whatever I can. So when they say more, it's going to go ahead and fetch the next page of information.
Yep.
But also sometimes what you might want to do, at least it used to be when you asked Alexa for like movies, it would tell you via voice that there were like, these are the 3 or 4, but definitely less than 5. But then if you've got an Echo Show, then it might show you a list of 10 or 20.
Mm-hmm.
So it would read off the ones that you had via voice, but then you could slide over and tap and take over with touch with a bigger result set. So
Definitely an important consideration. Another big consideration, though, especially when you're dealing with a lot of data, is, and this is surprising, how long it will take to send back the data.
Yep.
So you might say, well, my database record has for each movie, it's got, it'll return all of the theaters and all of the times for all the theaters and the prices for each one and
all the actors,
the list of the stars and
yeah.
I can get a huge chunk of data, so I might as well take it all. But returning all that data may take a second, whereas if you only return smaller chunks of that data, it may take half a second.
Yep.
And that doesn't seem like a lot, and I know I keep coming back to this, we only have 5 seconds to reply.
Well, and there's also strategies that you have to think of with that. I know it's different on Google, but on Alexa, you could put something in session storage, which means that it's kind of like a cookie or set of values that gets passed as part of the response.
Right. Session storage is the same between the two, more or less.
Okay. So it returns it back. And so then in essence on as part of the response, and then on the next request, those same values are passed back in. Well, that could add, depending on what you put in there, could add quite a bit to it.
Actually, that's a good point, because session storage size and response size is limited on both platforms. And I don't remember what the limit is, but you can't just assume that you can put, gigabytes of information and assume.
Oh yeah, you can't. Well, and what typically happens if you're doing something that that has a big result set and you're going through a list of things, and you also want to show the list of things in the UI with APL, then the APL that includes the list of items and the data is also being returned. So now you just got this data
double the size in some cases.
You've got the data in lots of different things, and so there's just a lot going on. And so you might want to use a strategy, instead of putting it in session state, put it in user state, which is usually then putting it into a database that you control.
Right, and this is the difference between Google and Alexa, is that there is a user storage that's done through the request and response system. So you don't have the latency of a database.
Yeah.
But actually, that's a good point also. Just because we can send it in the request and response doesn't mean we have to. If we have, a shared memory cache, for example, that all of our instances might be accessing, we might create a session storage there that we can store it in. And the response time will be a lot faster than going back to the database for it, but slower than using the request response method.
Yeah, that's true. But with like something with Dynamo DB, if you know like the user ID of the user and you're using that as the whole partition key for the value, then you're really treating it like a key value store. And so it's just going and grabbing just that item, and that's
that's pretty
really quick. Yeah. 100 milliseconds, something that's really, really quick. And so but remembering, like behind the scenes, every request that comes in at some point, that value is being brought in from the database, and right before the response comes back, that value in user data storage is saved back out to the database.
Yep.
So,
and those are the considerations that we need to keep in mind as we design these systems.
Yep.
And in some cases, if the data you're pulling from is Dynamo DB, does it make sense to store the session in Dynamo DB, or Do you just requery it again? That might be fine.
Yep.
Might not be.
Yeah, and there might be something where you start something and you start a query, and maybe that actually does kick off a query and results get put someplace. And then when you're notified that it's available, then you ask for it and you can pull it out. I've had situations where I'm using things in Dynamo DB and I only want them around for a certain amount of time. And so I actually set up there's a process that you can set up that would, in essence, delete it, which means pull it out of the results set, and then behind the scenes, it would actually, it has a time to live, and it will pull that out. Or you can look at something like Redis, which is an in-memory, really quick key value store that you can expire things out of as well. And so then you have the scenario where you pull something from the, that really is like a true cache, as opposed to kind of the makeshift cache that you're doing by storing things in session. But you could then query something, and if it doesn't come back, then from the Redis store, then actually call it from the data, the location, the API, or whatever it is, stuff it into the Redis cache, set an expiration on it, and then return the result set. And then you've got this added advantage of things being cached, ready to go really quick.
Yeah. So all sorts of caching solutions and database options that we have, and needing to make sure that we deal with pages and looping through results and making sure that one of the other interesting catches about looping through results, and again, I've seen this a bunch, is if you've got 3 results that you plan to return, your instinct in a lot of ways with the APIs that we tend to use, with both ASK and with Google's various APIs, is that you'll keep calling the equivalent of conversation add or result add or whatever. And you'll do that, 3 or 4 times because you have 3 or 4 results. That makes sense, right? Except that's not allowed. You're only allowed to send back a couple of simple results. And you call add multiple times and it says, why are you trying to send back 5 text messages when you're only supposed to send back 1 text message? So, and it's a simple solution. You need to build the response from all of these, and you should be doing that anyway. And this is where I plug multivocal as usual. Multivocal does that for you, but when you're just starting out, you don't think about, you think about sending stuff back by audio the same way you think about logging it to the console. You just call console log. You can call that as many times as you want. It'll show up on multiple lines. You can't do that with voice.
Yeah, but I think that's been a pattern or a need that's happened, and you solved it in multivocal, and Jovo in their version 4 has solved that as well, because you can call it multiple times to send back a message back, and then at the end it will say, oh, is this Alexa? I'm going to bunch this all into one message and reply that once. But if it's something like, I'm guessing, since I haven't actually done a Facebook Messenger, but if it's something that could have multiple results back, then it actually bubbles. Yeah. It actually sends back multiple results, and then it shows up as multiple bubbles or whatever in the UI for your chat bot or whatever it is.
Right. No, it's an excellent point. That again, and we've kind of touched on this a lot over the past bunch of weeks, is that our tools have, we've seen the patterns that programmers tend to trip up programmers, and our tools are now adapting to make it easier for the programmers to deal with that.
Yeah.
And I think that's super important. And as programmers, we need to be aware of it. But just like, we needed to be aware that once upon a time, JavaScript used events and then callbacks and then promises. Let's move things towards the modern way of doing it. And over time, we will move towards that modern way of doing things.
Yeah, move towards the newer versions of Node and the newer patterns that have been added to the libraries and frameworks that we use.
The newer libraries, just you don't need to stick to the skills kit and to the actions on Google library.
Yep.
There are better libraries out there. So did we cover everything about databases that?
I think I did have one last question. So this question that came up about Airtable, was the use of Airtable as a lightweight content management system?
I believe that's where Dana was going with this. And that's a good point. It's a common pattern to store the content that we want in databases of one sort or another.
Yeah.
And Airtable is really good because it's designed to be friendly to people who aren't developers and yet still give a way for developers to get the data out. So Airtable is very common for that.
Yeah, so like if your database was a SQL database or a NoSQL database like Dynamo DB, unless the developer puts some sort of a web or mobile front end on that for people to put content in, then then it's really the developers that are making content changes or data changes to the app, and that's where an Airtable or some other content management system. Ta-da!
I was about to say we're back on
useful.
content management systems again.
Yes.
There are so many more shows that we're going to be able to do about CMSs in the future. I know this. So yeah, I think Airtable provides an acceptable way to do that sort of thing. But I think it's marginally acceptable. There's still a lot that it means that we end up relying on the developers to do that we can't code in Airtable itself.
Yeah.
So I think it's understandable why we want to put more stuff into things like Airtable or into spreadsheets. But we need to find better. We need to build better tools, and I think we are. But no, yeah. An excellent point about using databases as that content store is a great and important solution.
And that's where you might start running into it, is once you want to externalize your content from your code, then that's probably where you're going to hit some sort of a database or data store of one flavor or another.
Yep.
Well, that's been a fun conversation.
It has. And not just because we got back to the subject of CMSs in the end, but no, databases get a lot of rap about being dull and laborious, but they're really, really important workhorses in our industry. And for developers who only have kind of a passing relationship to them, really behooves you to learn more about all the different kinds of databases that are out there and the different flavors and how some work better than others.
Yeah, I would bet that something like question of the day, maybe at some earlier incarnation, use something like an Airtable. It may still do, or a spreadsheet, or something. Maybe it's something custom now. I'm not sure, but that's a perfect example of, you've got a question every day, it's got answers, and there's a bonus question with answers. And that's not really a lot of information that you have to enter in. And you could do it you could sit down for an hour and do a week's worth of questions. But that's a perfect example of some sort of a data store that a content creator is using to feed that skill.
Yep. And another thing to keep in mind is that just because that's where the data starts doesn't mean that has to be where the data lives.
Mm-hmm.
So one very common pattern is to have, if you're entering your data in a spreadsheet, that's fine. But maybe it means that as part of the process, you upload that spreadsheet to something that then loads it into the database. So a spreadsheet may be the way that you edit the data, but you as a developer may pull it out of an SQL or MongoDB or Dynamo DB or something. And you've written a process, or somebody's written a process somewhere to convert it from the spreadsheet, or automatically pull it out of Airtable when there are updates into a more structured form that works faster, that works more reliable, that's on premises or whatever.
Yep.
So just because the data may originate someplace doesn't mean that's where it has to permanently live.
And I guess on the flip side of it is that you don't have to use a database for it. There might be a scenario where you've got this spreadsheet and you're publishing the spreadsheet, which is basically just saving a JSON file to an S3 bucket someplace.
Or
and
a CSV to a,
yep,
to a,
exactly. And then the code itself of the skill checks to see or pulls that value. And there's ways that you can do it where, since Node runs in a process, and if it's everybody's getting the same list of questions, then you could pull that in and cache it kind of at the process level. And then as requests are coming in, then it checks to see if it's already cached.
Sure.
If not, it pulls it, and that now you're using something that's really quick, just a query to an S3 bucket to get your data.
If you know that the question only changes once a day,
yep,
you don't need to go look at your database unless you don't have the data or it's the next day. So there's a lot of time that you can save in cases like that.
Yeah. So it's just kind of interesting. We want to think of the use case, and you don't have to use a database. There's some reasons to start small and go to a database, but there might be some reasons just to stay small.
Yep, definitely. So I think we'd love to hear what problems people are having with accessing databases. Again, thank you, Dana, for coming to me and inspiring this conversation. And I'm glad we were able to work out your problem. So, what problems have you had with databases? What tricks and tips do you have with the databases that you use for voice actions? We'd love to hear them.
Yep.
And we'd love to talk about them another time on Two Voice Devs.
Two Voice Devs. Take care, Alan.
Take care, Mark. Have a good week.
Thank you.